Okay, in this video we're going to be talking about plotting our potential density data, our mass and our volumes onto the graph that we just laid out and determine our go-bys. And notice the one thing I didn't say in the previous video was that we really want to stretch out our graph and use the majority of the graph paper all the time. We don't want to just be squeezing it in a corner. We really want to make that a lot larger. That way we can do some things called interpolating and extrapolating, where we go within or we go outside the data set in order to find some other things. But right now, here we have everything numbered nicely. We're now ready to plot these 4 points. So when we see 57.88 and 6.6, we have to go to the graph and we'll have to do a little estimating. Well, 57.88 is a little bit below 58, but certainly considerably above 56. So, about right there. And 6.6, here we have 6, 6.5. So 6.6 is about, 1/5 further than that. So about, excuse me, not be right. That'd be 6.1, not 6.6. So about right there. Good lesson is always double check your measurements. Okay. So here we take the 6.6 up all the way to 57.88. We plot our point. Okay, there's our first point. Second data point was 26.72 and 3.0. So we go and find where 26.72 is, 22, 24, 26. That's 28. 27 be in the middle. 26.72 is a little bit lower than the middle then. About right there. And 3.0, well, that's easy. There's 3 right there. So I'll follow my 3 line up. It's right there. Plot my point. And I made that a little bit too large. There we go. All right, next point then, 9.89 and 1.1. So I come down here to 10. This line will be 8, so 9.89 is way closer to 10. And if this is 1 and this is 1.5, I'm 1/5 the way after the 1. I go up to 9.89, put down my point. You can kind of see they're really starting to follow pretty much in a straight line. Okay, and then the next one was 64.04 and 7.2. Now 64.04 is barely higher than 64. So 60, 62, 64, it's practically going to touch that line. Okay, and 7.2, over here is 7, 7.5. So 7.2 is almost halfway, just a shade to the left of halfway. Go up to, keep going up, and right there's the point. And you can kind of see, now they're not quite so perfectly in a straight line. So I've got, here, let me darken those a little bit to make them maybe a little more noticeable. And there's really one other point I kind of technically probably do have. I really kind of have 0, 0, because if I had nothing, it wouldn't take up any space. So as I look to plot this line, I have to make what's called a best fit line. We do not do a connect the dots line. Absolutely do not do that. This would not be a best fit line. And anybody who ever taught you to take the first point and the last point and draw a straight line was totally wrong. Do not do that. That is incorrect. We've got to find where the average of these points is. And really to do that, I want about the same number above the line as below the line. If I kind of keep going up, going up, going up, right about there, I've got 2 points showing and I can't see the other 2 points, so it's 2 above, 2 below. I'll draw my line and I really should take it off the page. Do not just stop at the point. Continue that line, try and keep that. And make sure it's nice and straight. No wiggly lines, hold your ruler down tight. And as you can see, well, this happens to fall a little bit below it. This one accidentally really hit it. I did not do that on purpose. This a little below it, this a little above it, but they very tightly follow that line. I did not intentionally try and hit any of them. I just tried to go through the average. If you hit one by accident trying to go through the average, that's fine. Okay, so what we've done is made a best fit line. In the next video, we will be calculating its slope.